So in this video we're going to look at section 10.2, which is the chapter on annuities. An annuity is just a set of equal payments made at regular intervals. So we have two different types of annuity, an increasing annuity and a decreasing annuity. An increasing annuity is, for example, a college savings account. You make equal payments to the bank, let's say, every month, in order to generate this larger sum after, for a college savings fund, it could be 18 years. So you're going to make a set amount payment every single month for 18 years to generate that big amount. But you are also accruing interest on the amount that you've already deposited. In this particular section, we're just going to keep it more simple in that we will say that whenever we have compound interest, that compound interest, if it were monthly, also means that we are going to be making payments into that account monthly. So the regular intervals at which we make the payments, or with a decreasing annuity where we get the payments happen at the same time that we compound the interest, just to make it slightly simpler in our case here. A decreasing annuity is the exact opposite. A decreasing annuity is just where I have this larger sum of money at the start that is deposited, and then the bank will give me a certain amount, let's say every month, to live off of, or whatever it might be, for a certain amount of years until we reach zero in that account. But every, let's say, month, I am going to get this compound interest added onto my account. So not only am I taking money out of the account to live on, I am also getting interest on the money that still remains in the account. So I have an increasing annuity where I put money in to get a large sum out at the end, and a decreasing annuity where I put a large sum in at the start and then I take money out over time to end up with zero at the end. But in both cases, whatever is in the account is going to be accruing compound interest. A couple different things that I want you to be aware of in terms of definitions. The number that I end up with at the end of my increasing annuity, so the number that I have after, let's say, 18 years in a college savings account, okay, that will be the future value of the annuity, okay, because I've started out with $0, I've added in some every month, and then my future value is whatever I have at the very end. With a decreasing annuity, the number that I put in at the start, that large number, is the present value of the annuity. My future value will be zero because that account is going to diminish to zero as I take money out of it. Even though it's accruing interest, it will go down to zero in the end. So in our cases here, the large amount that we end up with in the increasing annuity is the future value. The large amount that we start with in the decreasing annuity is called the present value. I'm going to start off by looking at increasing annuities. There will be formulas to this, but I will tell you now that you will be allowed to take the formulas into any test or exam because they aren't the easiest ones to always remember. And what you can actually do is use a calculator to do some of this, but we will get to that in another video. But that calculator can be a good check. Let's say for an increasing annuity that we have N payments of R dollars, okay? So you are making N payments into your account over a period of time, okay? So let's say you have, I don't know, 120 payments over 10 years, so you're doing one payment a month, but you've got N payments and each one is R dollars. And each time you're depositing those R dollars into the account. And you get compound interest at a rate of I per interest period. So exactly the same as before. So I is just the interest rate per period. Okay, so let's say you had 12% compounded monthly. Okay, this is exactly the same as in 10.1. Then I would be that 12% divided by how many times you get paid in a year, which would be 12 if it's compounded monthly. The next value that we need to be aware of is R. R is just the amount that you pay into that account each period. So R it's actually called the rent, and it's the amount paid each interest period. So it's the amount that you pay into that account each interest period. So let's say you put $200 into that account every month. Okay, that would be that value R. And then N is just the number of payments that you make over a set period of time. Okay. And we are going to call F the future value of the annuity. That's how much is going to be in that account after however many months, years, etc. At the end, this is how much we will have in the account. Okay. We need to come up for some kind of formula to determine what that future value will be. So, for example, let's say I'm putting $100 a month into an account, and remember, however often we are paying into that account is also how often the interest is compounded. So if we pay in every month, then for our problems, we're going to assume that we're compounding interest monthly. If we pay in every quarter, we're going to assume that interest is going to be compounded quarterly. The other thing that we are also going to assume is that we pay into that account at the end of each period. Okay, so let's say that you open this account to put money into. At the end of month 1, I'm going to put money into that account at the same time that interest will be accrued on anything that's previously been put in. So it's being paid in at the exact same time as the interest is accrued. So the interest is not going to be accrued on the payment that's made on that same day. It's just going to accrue on anything that's come before it. Okay. So when we make our first payment, so let's say that we've got our payments here. When we make our first payment, the amount that we are paying in is our dollars. Okay. And then that R dollars is going to accrue interest for n-1 periods. Okay, it's not going to accrue any interest from that first period because you've just paid it in when that interest would be accrued. So we started off with $0 in the account. Let's say that we are doing this monthly. At the end of month 1, we have paid our dollars into the account, and we are accruing interest on the amount that's in there before. Well, we're still at $0 on that day until we pay that R dollars in. So we're not accruing any interest on day 1, but we are going to accrue interest on those R dollars that I put in for another n-1 periods, because I've only gone through my first period of paying out interest here. So that can still accrue interest for another n-1 periods. So the future value of that R dollars is going to be exactly how we looked at it in 10.1. Okay, the future value is always the present value of that amount multiplied by 1 plus I, where that's the interest rate per period, to the power of the number of payments, the number of times that the interest will be accrued. okay, the number of interest periods, which in this case is n minus 1. Okay, then let's say we're at month 2, end of month 2. Okay, you're going to pay another R dollars into the account. This R dollars is now going to accrue interest on that amount for n minus 2 periods. We missed the first period, okay, we missed the first month, there was nothing in the account until we put the R dollars in at the end of month 1. And then at the end of month 2, we've accrued the interest of the R dollars that's in from month 1. But this R dollars that we're putting in won't accrue interest until next month. So it's missed the first 2 periods of paying out interest. So it's going to accrue interest for n minus 2 periods, which means that the future value of that R dollars is going to be 1 plus I to the n minus 2 times R. So this is just the future value of this set R dollar amount on that particular, in this case, month. Okay? And you're going to keep going all the way down here to n minus 1, and then we'll look at n. So on the n minus 1th payment, again, you're paying in the R dollars, okay? You only have one pay period left, one interest period left for that R dollars to gain interest on it. So this time, the future value of that R dollars is 1 plus I to the 1, so just 1 plus I, multiplied by that amount. Then on the nth payment period, so this is the very last time that you pay in the R dollars, okay? Once you've paid in the R dollars, we're done. There are no more interest periods left. You are completely done. You've paid in the R dollars. Every other payment beforehand that you've paid into the account is going to accrue interest. That one's not, because once you've paid in on month N, you're done. That is however many payments that you wanted to make for the account. So you pay in the R dollars, we're done. So those R dollars are not actually going to make any interest whatsoever. So the future value of that is still R dollars, because there are no more interest periods left. So what is the future value of our account? Well, it's all of these added together. Okay, so our future value of the whole account is going to be all of these added up. Okay. I'm actually just going to call that future value F, because that's what we did at the start. That future value is F. I would like a nicer way of computing F that doesn't include so many of these terms. Okay, I would like a more compact version of it. In the textbook, they've actually gone about a way of doing this where they have multiplied the entire equation through by 1 plus I. You can actually go ahead and look at this on page 441. They've multiplied the whole equation through by 1 plus I, and then they have subtracted this equation from that equation. So they've multiplied the whole thing through by 1 plus I, and then done that equation minus this equation. When you do that, you end up with a nicer, more compact form for that future value. And that is 1 plus I to the n minus 1 over I multiplied by R. Okay, so my future value, my final value that I have in the account after I've paid in R dollars n times, is 1 plus I, where I is the interest rate per period, not just the interest rate that's stated, it's the interest rate per period like we did in 10.1, to the power n, the number of payments that you've made overall, minus 1, divided by that I value, multiplied by R. Remember, I is always done as a decimal, not a percentage in these equations. You can flip this around if you want, and you can actually find out, let's say you know how much you want in the account at the end. You know what you want your future value to be. So you want to know how many dollars do I have to pay in each period in order to end up with this amount in the bank account after n payment periods. Well, you can actually flip this formula around and find a formula for R, which is this. Okay. Like I said, these two formulas you are allowed in exams, so don't worry if you cannot remember them off the top of your head. It would be useful if you can, but like I said, I will allow you to have paper in the exam in order to have these written down. Okay, so the first example I want to go through is where we find a future value. The next one I'm going to do is where you find that rent, that R value, how much you actually have to pay into the account to end up with a certain future value. So in this case, I've got to find the future value of this increasing annuity where I pay in $150 per month for 10 years, where I've got in the account 3% interest compounded monthly. Again, like I said, however often you pay into the account is also going to be how often the interest is compounded, just because we are dealing with simpler problems in this particular chapter. So the amount that we pay every month is $150. The number of payment periods, well, I'm paying in every month for 10 years, so that's 120 payment periods. And then that interest rate per period, well, I've got 3% interest compounded monthly, so that 3% is divided over 12 months, so it's 0.03 divided by 12, which gives me 0.0025. So you go ahead and you plug those values in to our future value equation, and that gives me $20,961.21. Okay. The next example I want to look at is where I find the amount I would have to pay into the account each quarter to have $10,000 after 5 years if the account has 2% interest compounded quarterly. So again, I'm paying in every quarter, my interest is compounded quarterly. My future value is 10,000, that's how much I want to end up with. And then the interest rate per period, is my 2%, 0.02, divided by the 4 times that I pay that, or get paid that every year. So that's 0.02 divided by 4, which gives me 0.005. N, the number of payment periods that I have here, I get paid into the account every quarter for 5 years. So that's 4 times a year for 5 years, so there's 20 payment periods. And now I plug it into this formula, my rent formula, okay? And you plug those values in, and I find out that every quarter I have to pay in $476.66. There's one more thing I want to look at for these increasing annuities, and that is successive balances. What this looks at is if I have some amount at n months or n payment periods, and I have a particular future value in my account. What I'm going to do here is say, okay, let's say I want to do one more payment period. How much will I have in my account in the next payment period? Given what I have for my last payment period, given how much is in the account right now, how much would I have after my next payment period? Okay. So my new balance, I'm going to call it B new. Okay. It's going to be my old balance on the account, so however much I had currently, plus the interest that I earned on that old balance for that one payment period. So it's going to be my interest for a payment period multiplied by what I had in the account, plus how much I am paying in for that one extra payment period. So I'm just making one extra payment. So my amount in the account after one more payment period would be however much is in the account. So it's my current, basically my current future value, okay? That's how much I wanted in the account, plus the interest that I am accruing on that amount over this one extra payment period. So that's I times B old, plus one more payment that I'm making into that account. So one more R. Okay. You can also write this as 1 plus I times B old plus R. Okay. Let's go back to a previous example and look at what the successive balance would be. Let's look at this example. Let's say now I've got to this $20,961.21 and I'm just going to make one more payment into the account to finish it off. Okay. I want to find out the next month, if I made this one more payment into my account, how much would I now have after that one extra month? Okay, well, I would have this $20,961.21. Okay, and I will multiply that by 1 plus my interest rate per period. Well, my interest rate per period here was 0.0025 plus one more payment of $150. If you add all of that together, you should get $21,163.62. So you can go ahead and always find what the next amount would be given what you currently have in the account. So now we're going to look at a decreasing annuity. Okay. For a decreasing annuity, we start off with a lump sum that we pay into the bank at the start. Then, over time, we are going to take equal payments at equal intervals from that account until the account is diminished to zero. But during that time, the amount of money that is still in the account is going to accrue some interest, and it's going to be compounded at the same rate that you are withdrawing the money. So if you withdraw money, let's say $500 every month, we are going to look at problems where the interest is compounded monthly. If you withdraw once a quarter, then our interest is going to be compounded quarterly. So exactly the same as we did with increasing annuities, the rate at which you withdraw the money is also the same rate at which it is compounded. So keep that in mind. But for a decreasing annuity, it's the opposite to the increasing, where you start off with a lump sum and the account diminishes to zero as you take out equal payments from the bank rather than putting in like we did with an increasing annuity. If you go ahead and look in the textbook on page 443, they have actually gone ahead and found the equations, the formulas, to figure out what value you need to put in at the start if you wish to withdraw a certain amount each interval. And they've also got a formula to tell you if I've got X amount in my account at the start, this is how much I can take out each interval to get to zero in end payments. Okay, so they tell you what the present value, what the first value that you put into that account has to be. They've got a formula for that, and they've also got a formula if you need to find how much you can take out each interval. So if I want to determine what that present value is, how much I need in the account at the start, I use this formula. Okay. And then if I want to know the rent each month, so how much I can take out of the account each month, each interval, whatever that interval might be, if I start off with an initial amount in the account of P, so I know what that P value is now, and I know I need it to last N payments to me, how much can I take out? And this is the formula for that. Okay. And as normal, P is the present value, being the amount that you initially have in the account. So if you won the lottery, it would be the amount that you would get in your lottery winnings that you would put into the account at the start. R would be the payment to you each interval. So R is just the rent. It's the payment that you take out each interval. I is just the interest per period like normal. And N is the number of payments. Let's go through a quick example of this. So in this particular example, I'm going to be finding the rent. I'm going to find how much I can take out each period. So I'm going to deposit $20,000 into an account that accrues 4% interest compounded quarterly. How much can I withdraw at the end of each quarter for 20 years? So my present value, I paid $20,000 into the account at the start. Then the number of payments, how many times am I going to get paid out over 20 years? Well, I get paid out 4 times a year, quarterly, for 20 years, so N is 80. And then my interest rate per period is 4% divided by 4. And so my interest rate per period is 1%, 0.01. We plug that into our rent payment formula, and you find out that you get $364.38 a quarter. Okay. Same idea if you were doing the equation where you're trying to find that present value, where you're trying to find how much I need in an account given a particular rent payment. You're just going to use the other equation and plug everything in. I want to go ahead and actually show you how to do these on a calculator. This is always a good double check. I would always first go with what you get from the formula as the most accurate way of doing this, and you don't have to worry like you do on a calculator with positives and negatives. So this is always a great backup method that you can use, and you can use this for any of the stuff that we have done in 10.1 and 10.2. I'm going to go through 2 examples that we have done in this video on the calculator to show you how to do this. If you go to apps and click on finance and TVM solver, okay. The first example I am going to do is the one that we have just done in the decreasing annuities, okay? It will ask you a bunch of stuff here. N is the number of payments. So in the example that we just did, we found out that the number of payments that we got paid out was 80, okay? It was every quarter for 20 years, so N was 80. For the interest in the calculator, you do not do the interest rate per period, you do the interest rate as stated. So it said 4% interest compounded quarterly. You put in 4% here. You tell it that it's compounded quarterly down here. Okay, so we're going to say that the interest is 4%. Do not do 1% in this case. Always go with what it states in the question, and then you're going to tell it that it's compounded quarterly down here. Then the present value of the account. Okay, this is where we have to be careful with positives and negatives because we can get different answers depending on what we put. The present value, we pay the bank $20,000, okay? We deposited $20,000 into the account. If you ever deposit into the bank, so whatever money you give to the bank to keep, that is done as a negative value. Whatever the bank pays out to you is put in as a positive value in here. So my present value, my starting value of the account is going to be negative $20,000. That's how much I give the bank to look after. We'll come to the payment in a minute because I'm going to solve for that. That is actually the answer, as I've already clicked solve here. But we'll come back to that. That's the thing that we are trying to solve for. We were trying to find the rent. We're trying to find the payment. Future value is 0. We want the account to diminish to 0 after we've been paid out 80 times. And then the PY and the CY here, the amount of times you're paid and the amount of times that the interest is compounded in a year, both of those are 4. Okay, you're paid quarterly and also the interest is compounded quarterly. So both of those are 4. And the payment is always made at the end. Any problem that we do here, payment is always at the end of the quarter, the end of the month, the end of the year. It's always exactly when the interest is also paid out. So the payment you want end, okay? Then if we go down to here, where the payment is, what you want to do, again, like I said, I've already solved this. You would click alpha and then enter, and that would solve it for you. And again, this should come back as a positive number, that 364.38 if you were to round it, okay? Because that is the amount that the bank pays you each quarter, meaning it's positive. We gave them 20,000, so that went in as a negative, but because they are paying us the 364.38, then that goes in as a positive. So that's why that comes back as a positive value. So keep that in mind when you do these. The other problem that I'm going to do is actually the first one of our increasing annuities problems. So I want to go through one of those as well. So we were finding the future value of an increasing annuity of $150 per month for 10 years at 3% interest compounded monthly. Okay, so we know because it was monthly for 10 years, we said that N was 120. And then our interest rate, we said, was 3% interest compounded monthly. So in the calculator, I put 3% interest, and then my payment and my interest are both compounded monthly. So that means that I get paid every month and my interest is compounded every month. So both PY and CY go in as 12. My present value, okay, the amount that I start with in the account is 0. Okay, I'm paying in $150 a month, but that account starts out at 0. Then I am paying into the bank $150 a month. I am giving the bank $150 a month, which means that that goes in as negative 150. My future value at the end, which is the amount that they pay me, should come out as a positive, okay? So if I go down to the future value here and I click alpha and solve, I come out with $20,961.21, which is exactly what we got when we solve this using formulas, okay? So I highly recommend that you go ahead, do these using the formulas because we know that they are accurate, but you can always go ahead and double check on this TVM solver on the calculator. Just remember, whatever you pay to the bank goes in as a negative, whatever the bank pays you is a positive.